are you? This is Dua from Dr. Kevin class, Physics 2. I want to explain for you the electrical circle. I'm using my resource because we about to have our final and I'm really exhausted and I don't want to forget the stuff. So the electrical circuit is the simple circuit which contains a source, a light, a wire. When we can connect everything together, the light gonna be lightened. So that's because the electrical circuit is a path in which the electrons from the voltage here is the battery or current source keep flowing. So the point where these electrons enter, when the electrons enter at the battery, the entering point is got a name, it's got a call the source of the electron. Then the point where the electrons leave the electrical circuit is called the return or earth ground. The exit point is called the return because the electron always return or end up at the source when they complete the complete path of an electrical circuit. The part of an electrical circuit that is between the electron starting point and the electron and the point where they return to this source is called an electrical circuit or the load. A load of an electrical circuit may be as simple as the power home application like lamp, television, or something else, or complicated such as the hydroelectrical power generating station.
We're going to be solving some very simple equations for current. A steady current of 2.5 amps exists in a wire for 4 minutes. Part A, how much total charge passed by a given point in the circuit during those 4 minutes? Part B, how many electrons would it be? Our knowns are as follows. The charge, which is 2.5 amps, and the time, which is 4 minutes, and or 240 seconds. Our unknowns are the charge and the number of electrons. For part A, we have the equation for currents, which is I is equal to delta Q over delta T. By rearranging that, we come out that delta Q is equal to I times delta T. To find the total charge, we multiply the current, which is 2.5 amps, times the time, which is 240 seconds. And we come out that the total charge is 600 coulombs. To find the number of electrons, we have to multiply the total charge by the charge of the electron. Hint over here, the charge of an electron is 1.602 times 10 to the negative 19 coulombs. In case you're wondering how I got that number. So we divide 600 by 1.602 times 10 to the negative 19, and we come out that the total number of electrons is 3.75 times 10 to the 21 electrons. Our second equation is involving Ohm's law. A small flashlight bulb draws 300 milliamps from its 1.5 volt battery. Part A, what is the resistance of the bulb? And part B, if batteries become weak and voltage drops to 1.2 volts, how would the current change? So our knowns are the current, which is 300 milliamps, or 0.3 amps, and voltage 1, which is 1.5 volts, voltage 2, which is 1.2 volts. Our unknowns are the resistance and the change in current due to the change in volts. So the equation for resistance is volts divided by current. Our volts is 1.5 divided by our current, which is 0.3 amps, and we come out with 5 ohms. Now for part 2, the current, we have the volts, or volts 2, I should say, which is divided by the resistance. So we have the 1.2 volts divided by our resistance, which was discovered to be 5 ohms, and we come out with 0.24 amps or 240 milliamps. So we see that due to the drop in voltage, we also experience a drop in currents.